Today we'll go over what is Ohm's law. Just before we get into how useful it is and what it can do, let's talk about where it came from. George Simon Ohm. He discovered in 1827 that there was a beautiful relationship between resistance, voltage, and current. Now, of course, that's a simplified version of what he discovered, but for simplicity's sake, that's all we're going to cover for now. As mentioned previously, it's the relationship between resistance, voltage, and current. Basically, when one value goes up, the others get affected accordingly. Now, the symbols for them are as follows. R for resistance, V for voltage, and I for current. The I is basically current intensity. Now, to go along with all this, he brought us Ohm's triangle. Now, this beautiful little shape will tell you almost everything you'll need from a circuit and its components regarding their values. Here's how you would use it. You would first have to fill it in, and basically you just take these values and you input them. So, R is always here, resistance. I is always here, which is current, and your V is always here for your voltage. Now, this value may be an E, it really doesn't matter, it just depends on who's doing it. So to use it, all you have to do is take the value that you're looking for. So let's say we're looking for our voltage. We have our current and our resistance. All I have to do now is take the remaining two, see where they are respectively in the triangle, and I will apply the correct factor to them. So in this case, it's a multiplication. So I know that V is going to equal I times R, or vice versa. V equals R times I. Now, let's say I want to find my resistance. Well, now that changes things a little bit because now they're differently adjacent to each other. In this particular scenario, it's V over I. So now I know it's R equals V divided by I. And I'm guessing you can figure out what I would be, which would be I equals V over R. So this triangle just makes it easier because instead of having to memorize all three of these multiplication and division patterns, and there's tons more where this came from, you can just kind of look at the triangle and be able to solve from there. Now let's go about solving a simple circuit. So as you can see here, we have 6 volts coming from the battery. We have 100 ohms coming from our load, and we're trying to solve for current and resistance. Now, right off the bat, I know that I don't even have to do any math just to be able to solve my resistance. Because this is the only load in this whole circuit, I know that this is the only resistance in the circuit. So I'm going to be able to take my 100 ohms, that's what this symbol is, and I'm going to be able to put it over here, 100 ohms. So volts is the unit of measurement for voltage. Amps is the unit of measurement for current. And ohms is the unit of measurement for resistance. So now that I have my resistance and I have my voltage, I have 2 things that out of the 3. So now that I know what these 2 are, I can solve for I. So I'm going to bring my little trusty triangle over here, and I'm going to cover up I, and I can see that I need to divide voltage and resistance. So I'm going to go over here and go I equals V over R. I'm going to input my figures, which is 6 divided by 100. Input into my trusty calculator, and I'm going to get 0.06 amps. A is going to be my symbol, 0.06 amps. Now, that's pretty much it. We've solved for it. Now, let's say I need to double check. Let's say there's a potential I could have made a mistake in my calculation over here, and I'm not 100% sure. I can work backwards. Even though I have all my answers, I can still input them in reverse order or in a different order, and I should get the same answer every single time. So, instead of solving for I this time, let's try to solve for resistance. So, as I can see, resistance would be voltage divided by current. So I want to just write that out. So resistance equals voltage divide current. I'm going to put in my figures, 6 divided by 0.06. Put it into my calculator, and I'm going to get 100 ohms. And just like that, I'm going to cross-reference 100, 100. And now that I know that I did all this correctly, and I can move on to the next calculation, or this may be all I need. So thanks so much for watching. If this helped you, please subscribe and like, and see you in the next one.